Fresh. There we go. And, so share this. And, okay, so I keep saying okay like it's gonna start it. Let's go like that. And all right, so today we are starting a new unit. The new unit is called Variables, Conditionals, and Functions. The beginning of programming we talked about, or I talked about my sort of short list of like the 4 or 5 most critical concepts in computer science. These are 3 of them. If you guys aren't busy, this is what we're doing. Thank you. We've already done functions, but the reason we've already done functions is because the digital scene unit isn't part of this year's curriculum. They've changed functions into this unit, but I like that unit so much that we sort of squeeze it in there. But everyone else taking this course with, the regular average teachers, this is the first time that they are seeing functions. And actually, that'll be fine with that. You'll be familiar with a lot of the stuff once we get to it. This unit is, it's broken up into these 3 sort of chapters, with each one having like 3 or 4 lessons, and then like a kind of like a mini project, not like, planning guide and multiple days planning, that sort of thing, but like a culminating, 3rd day or whatever of the chapter. So that's where we're going with it. The first one, variables, we'll watch the introduction videos just so that we have sort of a shared vocabulary for the topic. But then, there's tons of little, mnemonic devices and sort of tricks for analogies for remembering the roles of these different things. Okay, so we're going to start with these first videos that if you are watching this later, we're watching these 2 videos here. It's not going to be on the recording, but you'll probably be able to hear it. Okay, so this is what we're doing. Please, 100% attention, pretty please.
Most apps keep track of pieces of information that change and update as you use the app. For example, a simple game can keep track of your score and the number of lives you have left as you play. Apps utilize the computer's memory to do this, and learning how to use that memory when programming is a really powerful skill. The most common way to leverage a computer's memory is by creating a variable. Now, a variable is just a container for storing a value. And once created, the variable is stored in the computer's memory, and it can be used and updated repeatedly throughout your program. As an example, let's use variables to keep track of the score and the number of lives remaining in a hypothetical game. Creating the variable is really easy. You use the word var followed by a label that you want to give to variable. You can choose any label you want, but it helps to choose a word that describes the variable that you want to store. So let's label our first variable score to keep track of the score. And then we can create a second variable to keep track of lives. Remember these labels. You'll need them later in order to use the variable. We can assign a value to the variable using the equal sign, like this. Let's set our starting score to 0 and our number of lives to 3. Remember, you only need to use the var at the time that you want to create a new variable. A common mistake is to use it every single time you want to refer to a variable. Also,
a bunch of you will do this, and by far most common mistake at this point is re-declaring state bar declarator.
So be sure to avoid mixing up the order when you call your variables. The label's got to appear on the left, and the value has to appear on the right, like this, not like this. Often, you'll want to create a variable and assign it a value right away. There's a really convenient way to do this with one line of code. This is sometimes called initializing the variable. It's important to realize that this single line of code is actually doing 2 things. First, creating the variable, and then second, assigning it a value. Let's take a moment to talk about the equal sign. In many coding language, the equal symbol is called the assignment operator because you use it to assign a value to a variable. And you're probably used to seeing it in math, but in programming, it's a little bit different. If you were in math class and you saw this, something would definitely be wrong. Score can't possibly equal both 5 and 7, but this is not math class. With code, a computer is executing a set of instructions, one after the other. So this would just tell the computer to set score to 5, and then on the next line, set it to 7. In an effort to avoid confusion, programmers often don't use the word equals when we see this sign. Instead, they use the phrase gets the value. So when we see a statement like this, we could read it as score gets the value 7, or score gets 7. Some programming languages avoid the confusion entirely by representing the assignment statements with a sideways arrow, like this. To use a variable, you just refer to it by its label. Anywhere the variable name appears in the program, the value currently stored in the variable will be retrieved from memory. The tricky part is that when using a variable, you often can't see visually what its value is. To bypass that problem, you can use write or console.log to display the value like this. This is a really handy trick, but remember there's a difference between showing the value of a variable and writing out the variable's label. When text appears in quotes, you're telling the computer to write those literal ASCII characters on the screen like this. But on the other hand, without quotes, the computer assumes that you're referring to a variable called score, and it will attempt to retrieve its value. If you haven't made that variable, then the computer will give an error. First variables video. In the first variables video, we learned how to create a variable, assign it a value, and then use it in a program. Now let's add some complexity. One of the most powerful things that you can do in a programming language is use variables in expressions. For example, var new score equals score plus 100. With this code, we're creating a new variable called new score, but we're not just assigning it a number like we have in the past. To calculate the value of our new variable, the computer must first retrieve the value of the variable score from memory, and then add 100 to it. The resulting number is the value of new score. What if we want to create a game where we increase the user's current score by 1 point every time a point is acquired? We could do this by updating the value stored inside the variable score based on its current value, like this. This line of code can be read as score gets the current value of score plus 1. So if the current score is 7 and the user acquires a coin, the computer must retrieve the current value of the score, which is 7, add 1 to it, making 8, and then store the new value back into memory. Similarly, in our game, if the player does something bad, we might want to reduce the number of lives by 1. So that code would look like this. Lives equals lives minus 1, or lives gets lives minus 1. This process of updating a variable is called variable reassignment. Understanding how variables are set and updated is a powerful key that unlocks many insights into programming. All good programmers can look at a piece of code and use what they know to trace through it logically. Let's try with an example that's sometimes a little bit tricky to newcomers. Check out this bit of code. In the first 2 lines, you can see that we have created 2 new variables, a and a b, and assigned them both initial values of 2. In the next 2 lines, we've updated their values so that they each get the value of a plus b. At first glance, you might think that a and b are both going to end up the same, but they won't. The key is to recognize that the value of a is being updated on the line just before b is changed. So what's being computed will change as well. Let's trace it out. When a gets a plus b, this will take the current values of a and b and add them together. The result of the equation is stored in the value of a. So as soon as this line of code is run, the value of a is changed to 4. With the next line of code, B gets A plus B. The sum of A plus B is now 6. This new number gets stored in the value of B, so the final outcome of the code looks like this. Variables are an extremely powerful tool in computer programming. By using variables, you can harness the power of your computer's memory to dynamically track important information while your program is running. Now let's get some practice.
All right. Of course, I don't expect you to even have a huge understanding of the topic from that, but at least, you've seen some of it and you have some, like I said, shared vocabulary. Go ahead and load up the current everything. If you go to the calendar spreadsheet, you will see that down here on line 107, it says current unit, variables, conditionals, and functions. That is how you're going to get to the current unit. That's why it says that. Okay. Just a quick update. If you have work to do from the previous unit, the intro to apps unit, of course, you get that from here. That's the way you get to that unit. And I'm not going to go over all the graded late work stuff right now. Everything's always posted. Things change, but at a reasonable pace, so you'll be all right. Okay, when you get to unit 4, variables, conditionals, and functions. You should probably only be able to see this first lesson intentionally. If you recall from previous lessons ones, not a ton of deliverables here. You can, the pre-unit pulse, go ahead and take a minute to look over that. Okay, first one. Okay, think back to the last unit when you're designing your own app. What features would you have added to your app or others from your class if you had more time and programming experience? So it's a quick reflection. And think of apps you use in daily life. Describe a situation where you can use an app to help decide something. That's a hint of something coming up. The decision app will be here shortly. Okay, I'll give you like 3 or 4 minutes to handle that. And then we'll keep going. Okie dokie. All right. So the actual first bubbles from this lesson, bubbles 3, 4, and 5, which I'm guessing most of you already took a look at, which is fine. Like I said, there's not a ton of deliverables here on the first few lessons. Okay. The key is about how in variables, it's all about keeping track of things, specifically as they change. And the example from the video, um, um, the example from the video of the game where it's keeping track of points and lives or coins and lives, that's a great example. Something runs, something happens, it changes. Things are going to be needed to be updated based on that new value. Okay. This basic clicker app, which will be within your abilities in a week or so, a few classes. There's not a ton going on. But the idea of right now, there's only one variable keeping track of or that's being kept track of, and total number of clicks. Okay. We're not going to do the share your thoughts thing. A lot of this you'd get more out of having some experience with variables, but that's fine. Okay. Variables aren't just going to be numbers, they are strings as well. Okay, so each of these buttons is adding or what's called concatenating. Concatenation. Concat is where you are connecting strings like train cars. And what's being output is that updated string. Again, more on that later. And okay, so you can try these combinations of username and passwords once it's running. And we're going to do something like this shortly. Oh, it is space sensitive. The basic username password thing, we aren't doing anything like network security or anything that would be, what you'd consider super private or secure. But we will be setting up username password stuff. But this home thermostat app that is just keeping track, you can tell it's keeping track of the Fahrenheit value and then converting it because the centigrade doesn't change every time. And if you know how you're converting, it's clearly rounding to the entire or to the whole degree Celsius based on the conversion. But again, not that hard. We're going to be making some of this either this class or next class. Okay. And so a nice little tour of variables and then a quick check for understanding, which being able to answer this is pretty much solely based on like the last minute of the second video. All right. But, I need my draw on the screen thing. The key to these types of questions, which you'll see a lot of, pardon the loading of my Active Inspire. The key to these types of questions where they give you a few lines of program code and ask what's the output of the variable or what's the value of the variable at the end of the as the program runs. The trick is getting a piece of paper and a pencil, a scratch paper, and following it through. Okay, this is not that difficult. And for now, we'll just go over this together. I'm not terribly concerned that I'm assessing your current knowledge. Okay, first line, var score. Okay, that's declaring a variable named score. That's all it's doing. Okay, and so after the first line, there's a variable named score. That's it. On the second line, score gets assigned the value of 3. Now, score is equal to 3. Okay, that line is run. The next line, score gets whatever it currently is plus 1. So score is now 4. Okay, and the next line, score gets a combination of this string, the score is, then concatenated with the current value of score. Okay, so it's this current, the score is colon, and then whatever is being stored in the variable score. Okay, So that's the analogy that we're going to work with, is a variable is just a container. Think of it as like a shoebox. That shoebox can hold something. It can hold a number. It can hold a string, word in quotes. Okay. That shoebox needs to have a name. You are creating the shoebox and giving it a name on the first line. Wherever you say var, saying create the shoebox. Okay. When you give it a name, that is, whenever you use its name, you have to give it a name to create it. But whenever you use that name, you're actually using what you're saying, whatever is stored in that shoebox at that moment. Okay. So here, when it's saying score gets assigned the current value of score plus 1, when this line started, or before this line started, score was worth 3. So score gets, at this point, it's 3 plus 1. Okay, so that's how we're working with this as the shoebox analogy. I guess it could be any box, but easier to visualize. Okay, let's go on to lesson 2. Hit refresh, you should be able to get to it. And let's investigate some apps. Okay, I think these are all where like bubble 1 is look at it and see, try to guess what's happening. And then bubble 2 is how does it actually work? It's probably worth our time. Okay. Excuse me. All right, so this is that home thermostat app without any centigrade conversion. We just have a single variable being stored, and it's whatever the value Fahrenheit, but it's just a number variable that is either increasing or decreasing. There's not that much going on here. All the label stuff and all the design stuff is just tied to that one variable changing. There's not a whole lot. Let's see what's actually happening. Okay. All right, so here on bubble 2, we have a variable named temp. Okay, it's declaring a variable named temp, and initializing it with the value 70. Okay, we almost always will initialize or give variables an initial value when we declare them, or at least declare the data type. Okay, so here we're declaring another variable called tempf, and it's being declared as an empty string. Now, we haven't talked about the properties of strings, but it is good to at least have this variable with the right data type so that you can use the properties that we haven't talked about yet later on. Okay, and then the rest of the program looks like 2 different event handlers. Okay, we're familiar with event handlers. It's waiting for the event of click to happen on down button, which this is down button. I think it's probably just like a, is it? Yeah, it's probably just a label or whatever. It's acting as a button. And the same thing for up button. And what happens when they get, when the event happens? Okay, the down button gives our variable temp, whatever it currently is, -1, otherwise known as going down by 1. And then this temp f gets whatever it currently, that new value of temp, concatenated with the letter f. Now, they are just sort of glossing over this huge issue called concatenation that I brought up a second ago. This plus sign right here is not addition. It is concatenation. Okay? Because one of the sides of the plus sign, this side, is a string, you can't add a string. There's not addition. It's not arithmetic. Okay? You can't add letters to a number and have a new larger number. Okay? You're concatenating, you're connecting like a train car. Okay? So that's how this is coming out. We are saying temp f, this variable that is just our words variable, is collecting this new updated version of temp and concatenating it with a space and a capital F. And that temp f is our output. This whole label right here is our new value of temp followed by a space and a capital F, and it's being set by the set text here. Okay, and the same thing, but the opposite is happening for the up button. The value of the variable named temp goes up by 1, and then it's set by that. Okay. All right, so what are we actually supposed to do? Okay, explain. This is if we were breaking it up. Okay, temperature goes up by 1. Modify the code so the temp goes up by 2 degrees. Okay, take a second. Some of you, this will take 0 seconds to do. Some of you are gonna snap out of it and figure it out shortly. Okay, figure out where the temp is going up by 1 and make it go up by 2. So hit go here. Okie dokie. All right, so the only area here that's changing a value is here on line 8 and line 17, okay, where the value of temp is being changed. Instead of having it go down by 1 or up by 1, we'll have it go down by 1 or down by 2 or up by 2. And there you go, nothing major. Okay, this most lesson is just to get you to see some use of variables. It's not a lot of programming, as you can tell, but being able to sort of dig through and figure out what's happening where is obviously important. Okay, read below, see, does this say, hold on a second. All right, okay, so we've got a new, this is kind of a check for understanding. Okay, read the code below. Notice how it's different from the previous version. Okay, we've got a new sort of block of code, the math.round. Okay, how do you think math.round works? Okay, we've got it here in 3 different places. Okay, take a second to think about it, and more than just it rounds the number would be the correct answer. I should say the correct answer should include something more than it rounds the number. Okay, give it a second. Okie dokie. All right, so um, it's not just that it rounds the number. The key, and when we start playing around with it, you'll see, is it solves everything inside of its parentheses and rounds the result. Okay, and you could tell because it's the farthest thing out. And as we get more into arithmetic inside of programming, arithmetic meaning addition, subtraction, multiplication, division, exponent, parentheses. Okay, you'll see it holds true to, order of operations, to PEMDAS. It starts on the inside and works towards the outside with the math.round rounding the result. You could have something else where like you rounded something and then did something with the rounded value, but that's not what's happening here. What's happening here is it's solving some arithmetic and then rounding it, which this is the equation for converting Fahrenheit to centigrade, in case you were curious. Okay, let's go on to bubble 4. Okay, and so now we get some extra variables to help us have a centigrade output. Who is this? That's ridiculous. Okay, so here, let's just take a look at what we have, and then we will run it. Again, rarely a bad idea to, oh, well, we've got this going super slow. Bad idea to just hit run when you get to a new bubble, just to see if it's broken, at least before you even look at it. But this pretty much works. Okay, so we've got 4 variables declared and initialized here at the top. That's another thing. The variables will always go at the top. They have to be declared first before you can use them. So the top of our programs will always start with a handful of var this, var that. Okay. It's also the only place we're going to use var until we start talking about local variables, which we won't for a long time. Okay. We are only using global variables, and that means the var goes at the top and it only goes once for each variable. Okay. We're declaring a variable named tempf and initialize it with a value of 70. Anywhere tempf is used, it's whatever it's referring to, whatever's in that shoebox at that time, but we never use var again for it. Okay, tempf only gets var the very first time. It is declaring, it's saying, it's inventing this shoebox. Okay, if we used var after that, it would be like reinventing it and wipe whatever value was in there, which is not what we want. The whole point is we are able to store that value in there and refer back to it. Okay, so yeah, so we have a new variable. Tempf is getting the value 70. It's a number variable. Then we get tempc, which is a rounding of tempf. Okay, these need to be put in this order because tempc refers to tempf in its value. Okay, and its initial value, tempc is the rounding of whatever tempf's current value is minus 32 times 5/9, and then round it. Okay, this can't be declared, it can't be initialized if tempf doesn't exist yet. If these were in the reverse order, this wouldn't work. Tempf doesn't exist when this line of code is run. It doesn't exist, I just switched it, it doesn't exist until after it. There's always a chance that AppLab lets you get away with things that are broke, things that it shouldn't. But let's see here if I can break it on purpose. Okay, let's put it back the way it goes. I'm going to run it, and tempc is going to be a console log output down here. There we go. 21 is the output. Okay, if I try to console log tempc before this variable exists, it's going to get not a number. Okay, we can't declare, we can't give tempc a value if this tempf doesn't even exist yet because it's on the next line. Okay, so the order of variables matter. They're always going to go at the top. Trying to think anything else. Okay, and then we have these 2 other variables, temp display f, temp display c, that are going to be our strings. There are output values, our output variables that are just collecting whatever the value of the other temperature variable, number variables, and concatenating them with the string of space and then capital F or space and then capital C. And that's how we're getting the output. Okay, we're setting the text of this text area called temperature F and this text area temperature C to whatever the values of these display variables are. Okay. There's a little bit of redundancy. You know, you could just say, let's set the value to that. But we'll be able to use this, or this program is able to use this a few times, so it is worth it. Okay, then we have the same things as before, a down button and an up button. And the same basic steps are happening. Okay, the down button changes temp F to get whatever it just was, -1. And up button, same thing, temp F goes up by 1. Then they each calculate the value of temp C, which is that same thing. It's the rounding of whatever the new updated value of temp F is, -32 times 5/9. round it, and that's what gets stored in temp C. Temp C is also a number variable, but it's based on temp F. Then we concat this new value of temp F and this new value of temp C with its letter, and then we set the text with these variables displayed, and then, of course, the sound effect. Okay, and same but opposite for the up button. Okay, how math.round works. Okay, delete lines 3, 5, 15, and 28. Delete math.round from 3, 15, and 28, which the easiest way to do that is to switch to text mode, which will require you to pay attention to which parentheses you're moving or getting rid of. Okay, you need to get rid of, well, you can actually do this by just deleting the words math.round and leaving those extra parentheses. Extra parentheses don't really hurt anything. Like if you had a regular arithmetic situation and wrapped it in 3 pairs of parentheses, it doesn't change the output. So if you literally just delete the words math.round from each of those lines, we are still going to get a centigrade output, but it's not going to be rounded to the nearest whole degree Celsius. Okay, and so that's what would happen. Were we supposed to speculate what happens? No. Okay, delete the space. Delete the space between in the quotations on line 4. Okay, so let's look here on line 4. We'll get rid of the space. And that space is part of this output, and that's why it's not there. But if you click up or down after that, because that space F is being reintroduced every time you click up or down, it undoes that issue. This space F is only being affected, or it's only affecting the initial display when it starts. But these other variable, or these other updates are reintroducing it. And I think that's it for bubble 4. Let's go on to 5. Okie dokie. All right, so another basic thermostat app where you can, it's the same as before, except it requires you to put in a name, or I guess it doesn't require, you can just hit login, but you can see where that shows up afterwards. It's gathered up and placed in the this text output, this text area, and everything works the same. Okay, let's go see what's actually happening on in bubble 6. Okay, investigate the code, what's being added. Okay, what's happening on line 40, and add an exclamation. Okay, so we'll just do this one together. Okay, everything here looks the same as before. We have these same 4 variables. 2 of them are storing numbers, and 2 of them are storing strings based on those numbers. But then we have this other one declared called username. And it's just declared. It's not given an initial value. We will almost always be giving variables an initial value, just to at least have them in the correct data type. And, oh, shoot, I forgot something. Either way, okay, same basic idea. We've got the down button and the up button. They still work. But we have another, actually another pair of event handlers, which, oh, neat. Okay, so the login button gives this variable username, which has been declared up here, it's giving its initial value of the word or the string hi comma space plus get text. Okay, again, if either side of the plus sign is a string, it's not addition, it's concatenating. Okay, concatenation. We are connecting train cars. Okay, the first train car is this string, hi, comma, space, and the second train car is this get text command. Okay, get text means it's going to be a string. It's being brought in as a string, but it's saying when this line of code is run, figure out, go find the text from the text input named name input, which is this text area here, and grab it and do something with it. In this case, they're getting the text of whatever text is here and concatenating it with our string that's already here, the high comma space. Okay, so we are creating a new variable. Well, the variable's already created. In this variable, we are storing this string and whatever text is in the previous text input, combining them, and that's the value of this variable. And that variable is what's being set up or what's being used to set this text here, the username text. Okay, and it also switches the screen to this screen. There's also a home button, which is this icon here. We'll go back to the main screen. It doesn't really do anything. But your job here, and we'll do it together, is to add an exclamation point on the end of this string. Okay, so it is a string. When you concat a string with anything, the output is a string. Okay, so we have this string that is, like I said, high space, comma space, whatever text is there, but we want to add an exclamation point at the end of this. There's a few ways to do this, but we're going to do it all in one line. And the thing about, and this is an easy time for you to mess up, so do listen. The easiest way to change strings or concatenating or whatever is to go into text mode. Now, when you are in text mode, you can very easily screw things up, and screw things up more than Control Z can fix, depending on what you screw up. If you do, I can always help you fix it. But you do need to pay attention to which parentheses and which semicolons and which whatever that you are using. Okay, so we are down here on line 40, and what I need is another train car. So our first train car is this string. It is connected with a plus sign. The second train car is whatever comes in as the name input or as the get text. And now I need a third train car. So I need a space, or I need a plus sign. I always do space plus space just to give it some space. Okay. And then I need an exclamation point. But you can't just do an exclamation point if you want it to show up as text. It needs to be a string. So inside of quotes, you need an exclamation point. So you definitely need to do this in text mode. If you try to do it in block mode, the plus signs and the orange blocks get ridiculous. It's so much easier, but you need to pay attention. The easiest thing to forget here is not putting a plus sign. I don't think it'll even let me. Yeah, it won't even let me go back. I don't know. There's a lot of things you could mess up. But this is what it needs to look like. Okay, we had everything up to here. Okay, please, again, paying attention to which blocks of code the parentheses belong to. Okay, this parentheses right here belongs to this one, which means you can't get rid of it. Okay, so the way you saw it when you got here, I'll do it from scratch again. Okay, this is the way it started. All we need is to go inside of the semicolon, space plus space, just to make it look good. The plus sign is the only thing that is affecting anything. This space and this space aren't. They just make it easier to look at. And so we want to concat it. We want to connect the train cars with a new train car, which is an exclamation point wrapped in quotes. Okay, so this is our new concatenation of 3 separate strings. The provided one, hi, the get text from our name input, and then the one we just wrote, the exclamation point. Those 3 train cars are connected and stored in the variable username. And then that's used to set the text here on the second screen. Okay, so if we put that in as a name, it's kind of hard to see, but there is a plus or an exclamation point there. And that's where that is how that works. Okay, again, they're just sort of glossing over the idea of concatenating. But yeah, concatenation, it's a big thing. Okay, and I think that's it for deliverables for this one. There is a check for understanding that, give me a second and I will go over it. Okay, so explain the process of creating, updating a variable. How does the counter pattern and event with event work? Okay, I can't remember if they said it before, but the counter pattern is the same thing that was in the video as all of the home thermostat apps. Essentially, just explain what's going on here. All right. Let me know if you have any questions.